Assalamualaikum warahmatullahi wabarakatuh, and good morning to Dr. HAIROL and my fellow friends. My name is Muhammad Ibrahim, DE1008, and our group has chosen the title of the relationship between upper voltage and speed. In this assignment project, we use simple linear regression from chapter C. The data is taken from the Project Sarjana Muda written by Muhammad bin Zainal, a student of FEE, University of Malaysia. We use the 100 data from FYP education student on DC brush motor for the experimental value. For the simulation, we use Microsoft Excel and SPSS software to demonstrate the simulated value. So here is our simulation. Here is our 100 data for voltage output and speed FPM, the independent and dependent variable. So right here we have already pop out our mean standard deviation value, minimum value, and maximum value. And we also pop out the slope and y-intercept value. So then when we graph our regression line, we can see that our y equation. So without any delay, I will pop out our graph. Just click here, insert scatter diagram. And here is our title. You can change it to the relationship between voltage and speed. So I want to speed up. And here we can see clearly that our data is over here. And if we want to make the intercept line clearer, we just click add straight line. And take it from here and we get our y value. And we can see that our y value is the same that we calculated in the Excel and the manual calculation. So that's all from me. Thank you.
Assalamualaikum and good day. My name is Nurdania binti Azama with matric number AE10066. Today, I will present about my part which is question 4.2c and question 4.2d. Firstly, for question 4.2c is we need to use the least square method to find the simple linear regression model. So here is the equation, which is y equal to b0 plus b1x plus epsilon. So we get the least square line equation. Then in conclusion, when output voltage is increased by 1%, the speed will increase by 293.01%. So here is the coefficient table. Then for question 4.2d, we need to check the significance alpha equal to 0.05 of the simple linear regression model in C. So here is the ANOVA table that I have made in the Excel. So let's move to the Excel. Firstly, this is our data. Then we need to select data and data analysis. Then we need to select the regression, then input y range with each speed, then x range, I put 99, then the residual plot, then the output range, which is I need to choose here, then okay. Then we get the table. Here is the table of regression, residual. This is the sum of square, means of square, figure, and significant figure. Here is the value. Then this is the coefficient table. So we compare to our result. So here is the same. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Arifanur Khalisha binti Khalid. My matric number is AE190057. So today for my part, I'll need to present E and F question. So question E need me to interpret the meaning of the intercept and slope in this problem. Before that, I'll show you the scatter diagram of our group. So the slope is defined as the ratio of change in speed to change in output voltage. To solve the question, we need to find out the effect of output voltage, which is in volt, and the speed, which is in RPM. So the slope obtained is 292.7510. Based on the slope, we know that as IV increase in output voltage, the speed is expected to increase by 292.7510 RPM on average. So next, for the intercept, it can be interpreted as the regression line crossing the y-axis. From this experiment, we got that the intercept value is negative 106.58. We can't interpret the output voltage that is below than 0.0 volt. So for F, we need to test the hypothesis, and this is our Excel calculation for this question. Next, for manual calculation, we got that TC is 1.981. H0 is reject when t-test is more than 1.981. Next, we need to calculate the SSE, MSE, and this is the formula of MSE. We put the value and we got this answer. And for t-test, this is the formula. We put the value into the formula given, and we got the value is 608.7612. The t-test value is 608.7612, which is more than the critical value 1.984. So H0 beta 1 equal to 1 is rejected. That's all from me. Thank you.
Assalamualaikum and hi, my name is Hussein binti Muhammad Nizar. My metric number is DE190155. Today I would like to explain about question G, H, and I. In question G, it asks us to test the hypothesis whether the intercept is equal to 0 against unequal to 0 by taking 5% level of significance. In this case, we are using two-tailed hypothesis test because the question asks about 0. By using the t-table, the critical value is 1.984. And the decision rule states that H0 will be rejected if t-test falls in the rejection region, which is modulus t is larger than 1.984. Then we find all the values of S, XY, SYY, SXX, B1, B0, SS, MSP using the formula given, and we test the t-test using a formula of constant, which is B0, because the question itself asks for B0, and we got the answer is negative 14.9810. The manual calculation is equal to the software calculation, which is the final answer is negative 14.9810. Before we find the final answer, we must find all these value first. Then we can conclude that since the modulus t is positive answer, which means t is larger than 1.984, thus the H0 being not equal to 0 is rejected. And the conclusion is the slope is unequal to 0. Next, the question asks us to compute the coefficient of Pearson correlation, and we got the answer as 0.9999. This answer can be proven by the software calculation, and we got the answer 0.9999. It shows us that the coefficient of Pearson correlation can be declared as positively strong linear relationship because the value 0.9999 lies in between 0.5 and 1. So the relationship between the output voltage and speed is positively strong. The last one, for question I, it asks us to compute the coefficient of determination and interpret the meaning. Then by taking the value of SSE and SYY that we have been calculated, we got the R to the power of 2 is 0.9997. The value 0.9997 in manual calculation is equal to the software calculation. Thus, we can conclude that 99.97% of the variation in speed can be explained, while the remaining 0.0003 is unexplained. Therefore, the coefficient of determination is strong linear relationship because the value 0.9997 is very close to 1. That's all from me. Thank you.